जरूरत होती है वो फोर्स इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन बिटवीन इलेक्ट्रॉन एंड न्यूक्लियस को बैलेंस करता है। और ये सेंट्रीपिटल फोर्स के लिए फॉर्मूला क्या होता है, mv²/r, और इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन के लिए क्या होता है, E²/4πε0r²। यह इलेक्ट्रॉन का मास होता है, v इलेक्ट्रॉन की स्पीड होती है, r ऑर्बिटल रेडियस होती है, ε0 को परमिटिविटी ऑफ फ्री स्पेस कहते हैं। According to Bohr's first postulate, I have right to write. What should I write? What I have written here on the board, mv²/r is equal to E²/4πε0r². v² is kept constant, m/r, this term can be transferred to opposite side, E²/4πε0r², r upon m. v² is equal to E²/4πε0r², r upon m. Suppose this is the equation number 1. What is the Bohr's second postulate? Electron revolves around the nucleus in those orbits for which angular momentum is equal to integral multiple of h upon 2 pi. This is Bohr's second postulate. That is, angular momentum must be equal to integral multiple of h upon 2 pi. Instead of capital L, I may write mvr, or you can understand angular momentum is nothing but moment of inertia and angular velocity, nh upon 2 pi. Instead of this I can write mr², instead of omega v upon r, nh upon 2 pi, rr get lost, mrv is equal to nh upon 2 pi, call it equation number 2. Squaring on both sides, m² v² r² v² n² h² upon 4 pi square, call it equation number 2. v² can be kept constant, m² h² upon 4 pi square m² r². What I have done here, I have squaring on both sides. This our equation can becomes like this: m² r² v² n² h² 4 pi square. v² is kept as it is, n² h² upon 4 pi square, and this term m² r² can be transferred to this side. So equation is going to become v² is equal to n² h² upon 4 pi square m² r². Suppose call it equation number 2. All these are equations are 2, or simply you can say this is equation number 2. Looking at equation number 1 and 2, we can compare these two equations, and after comparing these two equations, I may write here E² upon 4 pi epsilon naught square r² r upon m, which is equal to n² h² upon 4 pi square m² r². So 4 pi square, 4 pi and 4 pi get lost, r get lost, simply r is left, cadmium get lost. After simplification, after comparing these two equations, equation 1 and equation 2, and after simplification, what we get, R is equal to epsilon 0 square n square h square upon pi m e square. This is the equation for radius of Bohr orbit. After simplification, we get this formula, R is equal to epsilon 0 n square h square pi m e square. This is the radius of Bohr orbit. This is the radius of nth Bohr orbit. This term is constant, epsilon 0 n square pi m e square. Epsilon 0 square h square pi m e square. This term is constant. Means radius of Bohr orbit is directly proportional to square of principal quantum number. We can conclude that, we can write, what I can say, radius of nth Bohr orbit is directly proportional to square of principal quantum number. If I put epsilon 0 is the permittivity of free space, n is the principal quantum number, h is the Planck constant, m is the mass of electron, and e is the electronic charge. From this equation, all the terms are constant. Only radius of nth Bohr orbit is directly proportional to n square. That is, radius of nth Bohr orbit is directly proportional to square of principal quantum number. If I put n is equal to 1, then we can write Rn is equal to epsilon 0 square h square upon pi m e square. If you put n is equal to 1, then equation, the formula is going to become epsilon 0 1 square h square upon pi m e square. This is the radius of first Bohr orbit. This is the formula for radius of first Bohr orbit. Let's